This astronomical telescope can be used in two adjustments. The first adjustment being referred as normal adjustment. Now in this adjustment, an astronomical telescope is said to be in normal adjustment if final image formed after refraction through both the lens is situated at infinity. The course of rays in such an adjustment is shown in the figure. Now here A1 B1 is the image of distant object situated at infinity. If A1 B1 happens to be situated at the principal focus of lens E, the rays will emerge in parallel direction and a final virtual but magnified image is formed at infinity. The magnification with capital M in normal adjustment is defined as the ratio of angle theta I subtended by the final image at the eye as seen through the telescope to the angle theta naught subtended by object at the unaided eye when both image and object are situated as infinity. So we can write capital M as theta I over theta naught, and in terms of tangent of this angle we can write M is equal to tan theta I over tan theta naught using small angle approximation. Now in triangle A1 O1 B1, tan theta naught is A1 B1 divided by O1 B1, and in triangle A1 O2 B1, tan theta I will be A1 B1 divided by O2 B1. So we get the value of M as O1 B1 and A2 B1. So we get the final expression of capital M as A1 B1 divided by O2 B2 into O1 B1 divided by A1 B1, and this works out to be O1 B1 divided by O2 B2. Now here O1 B1 will be equal to FO, that is focal length of objective lens, and O2 B2 is equal to focal length of eyepiece. So the magnification for telescope in normal adjustment is FO over FE. Therefore, the magnification of astronomical telescope in normal adjustment is equal to ratio of focal length of objective to the focal length of eyepiece. The distance between the two lenses in this case will be FO plus FE. The strain on the eye will be least if the object is viewed for a long period. Therefore, in telescope, normal adjustment is a preferred adjustment. Now there is another adjustment which is employed in telescope, and it is the situation when the final image is formed at the distance of distinct vision. Now the course of rays in such an adjustment is shown in figure. A parallel beam of light coming from an object situated at infinity gets refracted through the objective O and produces a real inverted and diminished image A1 B1 at a distance FO from O1. If A1 B1 happens to be within the focal length of FE of the eyepiece, a final virtual but magnified image A2 B2 is observed. The position of eyepiece E is so adjusted that the final image is obtained at a distance of distinct vision D from the eye. Magnification in this case is defined as the ratio of angle theta I subtended at the eye by the final image formed at the distance of distinct vision to the angle theta naught subtended at the unaided eye by the object situated at infinity. So we can write the expression for M, capital M will be equal to theta I over theta naught, which will be equal to tan theta I over tan theta naught. Now in triangle A1 B1 O, tan theta naught is A1 B1 over O1 B1, and similarly in triangle A1 B1 O2, tan theta I will be A1 B1 over O2 B1. making the substitution, we get the expression for capital M, and it is O1B1 divided by O2B1, which gives us FO over minus U, where VU is the distance of A1B1 from the lens E. Considering refraction through lens E and using the lens equation, we can write 1 over FE will be equal to 1 over V minus 1 over U. Now in this case, V is equal to minus D, so we get the value of U as FE into D divided by FE plus D. Now it's clear from this equation that substituting for U in the equation we have just obtained, we get the final expression for magnification, and it is equal to FO in bracket FE plus D divided by product of FE and D. Now out of the two adjustments which we have discussed just now, the second adjustment gives a higher magnification, since the factor FO over FE in bracket FE plus D divided by D is greater than 1. So for a greater magnification, the focal length FO of the objective should be large and the focal length FE of eyepiece should be small. The objective of an astronomical telescope should have a large aperture so as to allow a large number of rays to fall on it. In that case, the intensity of image is large. This becomes even more essential in the case of heavenly bodies which are situated at large distances. A powerful astronomical telescope placed at Yaques Observatory at Lake Geneva has an objective aperture about 1 meter and a focal length of about 18 meters.